Good evening, children.
Good evening, ma'am.
Good evening,
Good
ma'am.
evening.
Good evening, ma'am.
Good evening, children.
Good evening, ma'am.
Good evening. Have you all completed the assignment given on Saturday? Yes or no, children? No response. So not done, is it?
Yes, ma'am. I did not do much, ma'am.
Okay.
Ma'am, I completed only one assignment. Ma'am.
Is it this one?
No, ma'am, that one assignment comprising of 6 questions, ma'am.
Okay, the other one. Okay, fine. Okay, then we'll do this now in the class. Fine. Take down the first question. Let's work it now in the class. Write down the first question, children. So what is the identity that is relevant to the numerator and denominator?
A cube plus B cube plus C cube minus 3 ABC.
Where is the minus 3 ABC term here in the numerator and denominator? In both the numerator and denominator, we can see only 3 perfect cubes. We don't have the 3 ABC term. Look carefully at the terms in the numerator and in the denominator. We have only 3 perfect cubes. We don't have the 3 ABC term. So which is the identity? A cube plus B cube plus C cube is equal to 3ABC if A plus B plus C is 0. Because we have only 3 perfect cubes in the numerator and in the denominator. So the relevant identity is x cubed, because we have ABC here. We'll use the identity using in terms of x, y, and z. So x cubed plus y cubed plus z cubed is equal to 3xyz if x plus y plus z is 0. So see here, I'll take you to the answer slide. So that's what we'll have to do in the numerator and in the denominator. So please watch, children, don't write anything. Yeah. So you can see here, we'll take up the numerator. We'll take up the numerator. This is the numerator. This is the numerator. So let x be equal to a square minus b square, y be equal to b square minus c square, and z be equal to c square minus a square. Now let's find x plus y plus z. So x plus y plus z. See, this is x cubed. This is cube. So x is a square minus b square. This is y cubed. So this is y, and this is z. This is z cubed. Similarly, here in the denominator also. So here we'll use identity in terms of PQR. Okay, so see P cubed. This is P. This is Q. And this is R. Okay, let's understand the numerator first, the factorization of the numerator first. So we'll call this one as x, this is y, and this is z. And let's find x plus y plus z. X plus y plus z. So you can see that a square minus b square plus b square minus c square plus c square gets cancelled. So x plus y plus z is 0. Therefore, x cube plus y cube plus z cube is equal to 3xyz. So which means this one is equal to 3xyz. 3 into x, which is a square minus b square, into y, which is b square minus c square, into z, which is c square minus a square. So this is how we factorize the numerator. See here, I'll repeat. X, y, and z. Find x plus y plus z. X plus y plus z is 0. Therefore, x cube plus y cube plus z cube is equal to 3xyz. So the numerator This is the numerator. This is the numerator. And what are the factors? 3xyz. 3xyz. You should not write xyz. X is what? A square minus b square. Y. This is x. This is y. This is z. And further a squared minus b, because it's factorization. We are factorizing. So further a square minus b square can be written as a plus b into a minus b. B square minus c square can be written as b plus c into b minus c. And c square minus a square can be written as c plus a into c minus a. So this is how we factorize the numerator. The same process in the denominator. Factorizing the denominator. This is the denominator. So we are using the same identity in terms of PQR. So like we're saying P cubed plus Q cubed plus R cubed is equal to 3PQR. If P plus Q plus R is equal to 0, don't get confused. Like we say X plus Y plus Z. X cubed plus Y cubed plus Z cubed is equal to 3XYZ if X plus Y plus Z is 0. Same identity. We are writing it in terms of PQR. Because here we already used x, y, and z. Let x be this, y be this, z be this. So we don't want to use x, y, z again. So this is p cubed. This is q cubed. This is r cubed. So then p is a minus b, q is b minus c, and r is c minus a. Find p plus q plus r. It is 0. Therefore, p cube plus q cube plus r cube is equal to 3pqr, which means the factors of the numerator are 3pqr. So see here 3, this is p, q and r. What is p? A minus b. What is q? B minus c. And what is r? C minus a. So like this, factorize the numerator and the denominator using this identity. Now find this one. So the numerator, this is the numerator. This is the denominator. So we factorize the numerator already. Here we already factorize the numerator, this one. So write it here in the numerator. And we also factorize the denominator. Here are the factors. Write them in the denominator. Then what happens? A plus b. Oh no, not a plus b. A minus b, 3 cancels. B minus c, C minus a. So the simplified form is a plus b into b plus c into c plus a. Because that's what remains. A plus b, that's what remains. A plus b into b plus c into c plus a. So the value of this expression given is a plus b into b plus c into c plus a. Right on, children? As you write, if you have any questions, any doubts, please ask. So why is it not this identity x cube plus y cube plus z cube minus 3xyz? Why is it not that identity here?
Ma'am, because there is no minus 3xyz term now.
Very good. Because we don't have the minus 3xyz term here at all. In the numerator and the denominator, we have only 3 terms. And the 3 terms in the numerator and the 3 terms in the denominator are all perfect cubes. They are like a cubed plus b cubed plus c cubed. So we have to use the conditional identity. This is called the conditional identity, what we've used here. Please let me know once done, children.
Finished, ma'am.
So quickly.
Yes,
Take a
ma'am.
picture and send. Let's see. So fast. So you were not listening to me then. I think you started writing as I was explaining.
I just started, ma'am. I didn't write the factorizing numerator and stuff. I just started the method.
Done, children?
Not yet, ma'am.
Okay. Yes, children. Hurry up. Done, children?
1 second, ma'am.
Okay, so I think that is good amount of time I gave you. You must have done by now, children.
Completed, ma'am.
Yeah. Yeah, class, use the emoji. Raise your hand. Sanjay, Sindhu, Krishmika, Shri, Prajit, Danya, Raja, Madhumita, Arjun, Srijana, Krishmi, Dishant. Shreyas, Tanishka, is it? Okay, yeah, I can see. Very good. All right, children. This is the next one. Factorize the expression given. So how many terms, children? How many terms?
4, ma'am.
4 terms.
4, ma'am.
How many? Very good. 4 terms. How many perfect cubes?
3. 4, ma'am. 2, ma'am. 2.
Yes,
8
others?
can be written as a perfect cube.
All of you agree? 2 perfect cubes? 3. Okay.
3.
How is it 3? Which is the third
3,
perfect cube? Apart from the first 2 terms, which according to you is the third perfect cube? This is a perfect cube. This is a perfect cube. Which is the third one? Yeah, only 2. So we have only 2 identities. We have only 2 identities, which have 4 terms with 2 perfect cubes in them. And they are a cubed plus b cubed plus 3a square b plus 3ab square is equal to a plus b the whole cube. This is one. And the other one is a cubed minus b cubed minus 3a square b plus 3ab square is equal to a minus b the whole cube. See, children, the terms you can write in different order. These are the 4 terms. You can write them in different order. Why, Sindhu, you're distracted? You're seeing somewhere else? Okay, so okay. So these are the only 2 identities which have 4 terms with 2 perfect cubes in them. Now tell me, now the given expression relates to which identity? Or the given expression can be related with which identity here? The first one or the second one?
A
Either
minus
of the 2, ma'am.
The second one, right? Because of the signs. Because of the signs. So it's very easy to identify the correct identity. Very easy. These are the only 2 identities. These are the only 2 identities in which you have 4 terms here. 4 terms here. Of which 2 are perfect cubes. Of which 2 are perfect cubes. These are the only 2 identities which have 4 terms. 4 terms with 2 perfect cubes, a cube plus b cube, a cube minus b cube. Now you have to select which one of the 2 you must use to factorize the given expression. So clearly it is this one, the second one. We have to use the second one. Yeah. So see the answer slide. So see here, children. I first arranged it. So this is a cubed minus 3a square b plus 3ab square minus b cube. Now your doubt may be like, how do you know that this will be the 3a square b term? From the sign you can make out. From the sign, use the signs and arrange the terms. See, this is a cubed. You're taking this as a cubed. And of course, this is b cubed. So a cubed minus. So this should be the 3a square b term plus 3ab square minus b cubed. From the signs you can identify a cubed. In the first step, I've only rearranged a cubed minus, no, so this should be 3a square b plus, so this should be 3ab square and minus b cubed. So that is what you present in the next step. In the next step, what you do is a cubed. So 4 by 5x the whole cubed. So this is a and this is your b. This is your b. So now we have identified a and b. From a cubed and b cubed, you have identified a and b. So now complete this. 3a square b from the identity. 3a square b you will have to write 3. This is a square b plus 3a. See, this is a, right? A b square, b square. Now, when you work this one, when you work this, you can see the bracket below. When you work this, you will get 96 by 25 x square. And when you work this, it will be 48 by 5x. So clearly, the given expression is of the form a cubed minus 3a squared b plus 3ab squared minus b cubed, wherein your a is 4 by 5x and b is 2. So the given expression can be written as a minus b the whole cube, a minus b the whole cube. This is the question. This is the question. So this is the answer. One side of the identity is the question. The other side of the identity is the answer. So the answer is a minus b the whole cube, which is a minus b into a minus b into a minus b. So first step, I've rearranged the terms. Second step, you'll have to show that it is of the form a cubed minus 3a squared b plus 3ab squared minus b cubed. You will have to present it like that. For that, you need to first identify a and b. A and b. So once you identify a and b, 3a square, right? A and square, b. 3a b square. And I told you, when you simplify this, you will get 96 by 25 x square. When you simplify this, you will get 48 by 5x. They are the terms here or here. Yeah, right on, children. Done, children?
Completed, ma'am.
Yeah. Others?
Completed, ma'am.
Yeah.
Completed, ma'am.
Fine, children. So how do we work this? P of x, g of x. Is P of x a multiple of g of x? What are we supposed to do?
Ma'am, we should split the middle term of g of x and find both the factors, ma'am.
Okay.
And if it's divisible by either of those, then it's a multiple.
If it's divisible by both of them, Not either of them.
Yes, ma'am.
Okay, but how do you check if P of x is divisible by both the factors of g of x?
We can divide it by g of x, ma'am.
Oh, you said we'll have to split the middle term. What will you do with the two factors next?
Ma'am, like if it's x minus 2, then we're supposed to put 2 as p. We should find p of 2, ma'am.
Okay, use the remainder theorem. Okay. So supposing x minus 2 and x minus 5, so find p of 2 and p of 5. If both is equal to 0, then p of x is the multiple of g of x, correct?
Yes, ma'am.
Correct. I don't know how I worked it here, but you can also use a long division. You're right, Madhumita. You can do it that way also. Or you can also use a long division. If the remainder is 0, it's a multiple. As Madhumita said, we can also do this. We can split the middle term. So g of x is equal to x squared minus 3x plus 2. So split the middle term is equal to x squared minus x minus 2x plus 2. So is equal to x into x minus 1 minus 2 into x minus 1. So x minus 1 into x minus 2. So let's find, to find p of 1 and p of 2, because x minus 1 is equal to 0, x will be 1, and in the other case, x will be 2. So to find p of 1 and p of 2 and p of 2, if both p of 1 and p of 2 is 0, if both p of 1 and p of 2 is 0, then g of x is a, or sorry, p of x is a multiple of g of x. So you can also work it like that. You're right, Madhumita. So for that, to use a remainder theorem, the factor has to, the expression has to be a linear expression. To use a remainder theorem, the expression should be a linear expression. So you have to, g of x is quadratic. G of x is quadratic. So you will have to find the two linear factors by splitting the middle term. The two linear factors are x minus 1 and x minus 2. So when you equate each of them to 0, you will get x is equal to 1, x is equal to 2. So find p of 1 and p of 2. Both of them will be 0. Conclusion, p of x is a multiple of g of x. I've done the long division. Whichever method, children, please complete it. Srijana. Srijana. Nishant.
Completed, ma'am.
Yeah. Anybody still working?
Ma'am, 1 minute, ma'am.
Completed, ma'am.
Yeah. Resolve this expression into factors. Yeah, I want the answer from you. Give you 3 minutes time. It's a very simple one. Yes, who has the answer? Yes, children. No, it doesn't take this long, children. It shouldn't take this long. I'm not discouraging you. But this is the truth. It shouldn't take this long. You should have finished 3 times by now.
It's factorizing, right?
Yeah, yeah.
Finished, ma'am.
Yeah, tell me.
The factors are b plus 3a and a minus 1.
A plus 3A
And b plus 3a and a minus 1.
A minus 1, is it?
Yes, ma'am.
Can I have your steps?
Yes, ma'am.
Read out your steps.
That's 4 terms, ma'am. So I have a factors directly, ma'am.
Yeah. Tell
A
me.
cube minus b cube plus 3ab plus 1. I have taken b common, ma'am, and I've done it.
B common between which 2 terms?
A minus 1, ma'am. A and b. I'm sorry, ma'am.
You can flip the pages and see, children, we have already done the sum once earlier, maybe even twice, but once I remember for sure. Okay.
Ma'am, I think it comes under formula a cube plus b cube plus c cube minus 3abc. But I'm
Perfect.
confused that there is no c term, ma'am.
Okay, now you said it looks like a cube plus b cube plus c cube. Now, which is your c cube?
One cube.
One. No, then how will you find the c term? You will only have a and b because c is a number.
Yes, ma'am.
You're right. You've identified the identity correctly. A cubed minus b cubed plus 1 plus 3ab. You need to rearrange the terms like this. Now this expression has 4 terms with 3 perfect cubes in it. See, this you need to first understand the different parts of the expression and identify the correct identity. That's what is important. A cubed minus, see, a cubed, perfect cube, b cubed, perfect cube. 1 is also a perfect cube, plus 3ab. 3ab is not a perfect cube. It's just a term, 3ab. So there are clearly there are 4 terms. And of the 4 terms, the first 3 terms here are perfect cubes. There is only one identity. There is only one identity which has 4 terms on one side with 3 perfect cubes. And that is what Tanya just shared. That's the only identity. X cubed plus y cubed plus z cubed minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus xz. This is the only identity which we know in our syllabus. Okay, so this is the only identity which has 4 terms with 3 perfect cubes. This is the only identity. So there is no difficulty. You don't have to choose between this or that. There's only one. So you can see it here. You can see it here. I've rearranged and you should show that it's in the form a cubed plus. Take the signs from the identity. Take the signs from the identity. It should be like x cubed plus y cubed plus z cubed minus 3xyz. So see here, x cubed plus y cubed will be minus b the whole cube plus z cubed plus 1 the whole cube minus all the signs from the identity. Please take the signs from the identity. See here, x cubed plus y cubed plus z cubed minus 3xyz. So this is your x, this is your y, this is your z. First step is to rearrange. A cubed should be written as a the whole cubed. You should not write this minus sign. It is plus y cubed. So you must put the plus sign from the identity. You should put the plus sign plus y cubed. But it's minus b cubed. So it will be minus b the whole cube plus z cubed plus 1 the whole cube minus 3xyz. So minus 3. This is x. This is y. This is z. X, y, z. Now, when you simplify all this, you will get a cubed minus b cubed plus 1 and plus 3ab. So once you show that the question is of this form, This is the question. So this is the answer. This is the answer. X plus y plus z, x square plus y square plus z square, minus xy minus yz minus xz. Done, children?
Completed, ma'am.
Yeah.
Completed, ma'am.
Yeah. So children, remember that this is the only identity which has 4 terms with 3 perfect cubes. So this expression, 4 terms, 1, 2, 3 perfect cubes. And this 3AB, it's 3AB, it's not 3ABC because the C term is 1. So 3ABC, you will not find the C term. AB is there. But since C is a constant, C cubed is 1 cubed. That's why it's just 3AB. I have nothing to explain in this. Please work this.
Completed, ma'am.
Yeah.
Just a minute. ma'am.
Yeah. So minus 1 raised to an even power. Minus 1 raised to an even power. So that means minus 1 is multiplied with itself 100 times because the power is 100 and 100 times, even number of times. So minus into minus is plus. So when it's multiplied even number of times, it will be a positive 1, plus 1. But when minus 1 is multiplied with itself 101 times, odd number of times, the answer will be -1. When it's a positive one, whether it is even number of times or odd number of times, it will be a positive one only. A positive one, +1. When +1 is raised to an even power or an odd power, the value will always be 1 because the base is just 1. It's +1. So whether it is even or odd power, the answer will be 1 only, +1. +1 raised to an even power is +1. +1 raised to an odd power, +1 only. -1 raised to an even power is a +1. A -1 raised to an odd power will be a -1. Yes, Prajit?
Sorry, my mic. I unmuted accidentally.
So be very careful in writing the values. This is 1, this is 1. Here it's even power, so it will be a +1. Here the power is odd. Odd. -1 is multiplied with itself 101 times. So like if you have odd number of minus signs, like say 3 minus signs, minus, 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 minus into minus plus, plus into minus is minus. When you have even number of minus signs, 1, 2, 3, 4, even number of minus signs. So minus into minus plus, minus into minus plus. So if there are 100 negative signs, minus 100 times, you understand? You can pair them. 2 minus signs will become plus. So like that, negative signs 100 times will be positive. But 101 times, so 1, 2, 3, 4, 5, odd number of minus signs, minus into minus plus, minus into minus plus, plus into plus, plus into minus is minus. So here it is 1, but here it's 1, here it is -1. And then minus into minus plus 1 plus 1, 2. Yeah, please factorize this and tell me the answer. Done, children?
Ma'am, when we I figured how to do it, but when we split the middle term, only 11 power 7 is the total sum, ma'am.
What's a total sum?
11 to the power 7, ma'am.
11 root 7. Huh?
11 root 7, ma'am.
Oh. Okay, we'll just wait for the others also to try. I'll share the answer. Class, use the emoji. Raise your hand. Arjun, are you there? Okay, so Prajit, Madhumita, Lishant, Raja, Tanishka, Krishmi. Krishmi is there, but Krishmi, you don't communicate at all. Please participate, share your answers, ask questions if you have any doubts. Please let me know that you are there. Srijana also. Please participate in the class. Are you there, Srijana?
Yes, ma'am.
You went through the recordings which I shared with you, Srijana?
Yeah, ma'am.
Okay, I'll talk to you sometime tomorrow. Okay.
Yeah.
This also, children, shouldn't take this long. 1 more minute.
Ma'am, when I split the middle term, 210 is the sum of 6 root 7 and 5 root 7, but the product is 11 root 7, ma'am.
Okay, maybe I hope the question is not incorrect. Let me try. Let me try. Okay, so I think nobody is able to factorize this. So let me just check. Minus 210. What is the sum, children? What is the sum?
13 root 7, ma'am.
13 root 7. Product?
210, minus 210, ma'am.
Minus 210. What are we supposed to do? Take up 210, right?
Yes, ma'am.
Yeah. So we'll start with 2.
Yes, ma'am.
How many times?
105, ma'am.
Yeah. Then 3.
335 times, ma'am.
35 times. Yeah.
Yes, ma'am. And then 7 5 times, ma'am.
Yeah. And 5 answer. Yeah. You're right. So 5. Oh. Yeah. Think a little more, Madhumita. You can find the factors. Please think a little more. It is correct. The question is correct. again, disappointing that you're not, sorry. So children, these are the numbers, all right. So we have 210 is equal to, please listen to me, all of you. 210 is equal to 2 into 3 into 5 into 7. Any order you can write. Any order you can write the factors. Now, since the sum has root 7, we need to write 7 as root 7 into root 7. Because we need to get the sum as 13 root 7. Which means you need to write 7 as root 7 and root 7. So 210 can be written as 2 into 3 into 5 into root 7 into root 7. Supposing the sum had a root 5, then we need to write 5 as root 5 into root 5. But since the sum has a root 7 in it, you need to write 7 as root 7 into root 7 because you know root 7 into 7 is 7. Now we need to get the sum as 13. So let's group these two. This will give you 15 and this is 2. And you know that 15 minus 2 is 13. You know that 15, you'll have to make use of all the factors to find the two numbers. You will have to make use of all these factors of 210 to find the two numbers that will satisfy the sum and the product. And since it's 13 root 7, you know that 5 3s of 15 minus 2 is 13. So 5 3s of 15 and 2. Fix 1 root 7 for 15, fix 1 root 7 for 2. Like this, we have made use of all the factors of 210. See, we've made use of 2 2's here, 3 and 5 is here, and 15. Root 7, root 7. There's one here, one here. We have made use of all the factors of 210 and got these two numbers, 15 root 7 and 2 root 7. Both the numbers should have root 7 in them. Only then you will get the sum as 13 root 7. Now the next step is to fix the signs. The next step is to fix the signs. The sum is positive. So the greater number must be positive. The sum is positive. It's a positive 13 root 7. So the greater number should be positive. But the product is negative. So this one should be minus. So the two numbers are 15 root 7 and 2 root 7 and 2 root 7 minus 2 root 7. So you can see 15 root 7 minus 2 root 7 is 13 root 7, the sum 13 root 7. And when you multiply these two numbers, you will get minus 210 because you will get 210 because we have made use of the factors of 210. The product will be 210. The product will be 210 and it will be minus 210 because this is negative. And then you will have to split the middle term using these two numbers. Group the first two terms, last two terms. Yeah, children, complete the answer using this slide. Again, you should be careful here while taking out the common factor between these two, the HCF. So how do you make out it is 15 root 7? How do you make out it's 15 root 7? See here, in 210, what do you have? This is what you have in 210. What is 210 made up of? Can you see 2, 3, 5, the 15 root 7 in it? Children, please listen to this. Between these two, between the third and the fourth term, you need to find the HCF of 15 root 7 and 210. Go back to the factors of 210. Go back to the factors of 210. What is 210 made up of? It's made up of 2, 3, 5, root 7 and root 7. Now, the HCF of 15 root 7 and 210 is what we're trying to find. See here, 5 3s of 15 root 7. 210 is made up of 15 root 7. So 15 root 7 is the HCF. And when you take out 15 root 7 common, What will come inside here? It will be 2 root 7. The factors that are left out, 2 root 7. 2 root 7. I repeat, between these two terms, the HCF is 15 root 7. How? Look at the factors of 210. Do you find 15 root 7 in it? See here, 5 3s are 15 root 7. Yes. We
Yes,
find
ma'am.
15 root 7 in 210. So take out 15 root 7 common. So 15 root 7 into x is 15 root 7x. Plus into minus, minus. 15 root 7 into 2 root 7 will be 210. Will be 210. You can make out from the factors of 210. It's not at all difficult. If you take out 15 root 7 common, 15 root 7 common, what is left in the factors of 210? 2 root 7 is left. So 15 root 7 into 2 root 7 will give you 210. Done?
Completed, ma'am.
Yeah. See, you can find, you can, it's not that you should use the factors in the same order. The other numbers which you can get are maybe you can group like 2 and 2, 5 and root 7. See, you can group 2, 5 and root 7 and get 10 root 7. And you can group 3 and root 7 and get 3 root 7. Now you will think that this also gives 13 root 7. Then why you should take, these two numbers? So with this, you will get the sum. You may get the sum as 13 root 7, 10 root 7 and 3 root 7. I hope you're all listening to me.
Yes, ma'am.
Yeah,
Yes,
so
yes.
I'm just, yeah, children, good. So now see here, 2 5s are 10. 10 into root 7 is 10 root 7. Can be one number. 3 into root 7, 3 root 7. I told you, you must make use of all the factors of 210. You should not miss out any factor. You must use all the factors of 210 and find the two numbers. So these could be two numbers which satisfy the sum 13 root 7, but not the product. You will get the product as 210, but you will not get minus 210. When you multiply 10 root 7 and 3 root 7, you will get 210. Why will you get 210? Because they're the factors of 210. Then why will you not get the product as 210? You will get 210. But the sign is minus. Minus 210 you need to get. No, that you cannot get. So when you write 10 root 7 and 3 root 7, you have to take both positive because only then you will get a positive 13 root 7. If you just because the product is negative, if you fix a minus sign to any of these, then the sum will not happen. The product will happen, but the sum will not happen. If you think, okay, the product is negative, so let me put a minus sign here, then the sum will not happen. 10 minus 3 is 7 root 7. So maybe, so as I told you, you can get 10 root 7 and 3 root 7, but these two numbers with you try plus, minus, 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 whatever signs will not satisfy both of them, may satisfy one of them. You may get the product or the sum, but you will not get both the product and the sum using these two numbers. So otherwise you can make like 6 root 7 and 5 root 7, 6 root 7, because 2 3s are 6 and root 7, 6 root 7 and 5 root 7 and 5 root 7. 6 root 7 and 5 root 7 will give you 11 root 7. So you're not getting the sum. You will get the product. You will get the product. As I told you, you're using the factors of 210. So when you multiply them, you will get 210. But you're not getting the sum. So the two numbers are unique. All of us will get the same two numbers, which satisfies the sum and product. You cannot get a different pair. And to find the HCF, you should go to the factors. You must go back to the step where we have the factors of 210. You must see, what you have. We have 15 root 7 here, and you have everything here, 15 root 7. So the entire thing, 15 root 7 is common. 15 root 7 into x is 15 root 7x. And 15 root 7 into what is 210? The remaining factors, 2 root 7, 2 root 7. Is it fine, children?
Yes,
Any
ma'am.
questions? Okay. Is this the other paper which I shared? No, not this. Yeah, I think it's this one, right? How many of you worked this? Raise your hand. How many of you have worked this paper? Danya, you said you worked this one, right?
No, ma'am, it's not this. Another one, ma'am.
Oh.
That has 6 questions, ma'am, and as A and B. 5 and 6 has subdivisions A and B.
These are the only two papers which I had shared the other day for assignment. Yes or no, children? This is the other assignment, right? Please answer, children.
Yes, ma'am.
You've all taken screenshots, right? This is the other paper. I remember this is the other paper which I had shared as assignment. Okay, so nobody's worked it. No, actually, now I understand that children are so busy with school, school conducts so many tests and you have to write a lot of notes, this and that. You're so busy with school. Before 2020, you don't know, I used to give children weekend assignments also, and they had time to complete all of that. They were not so busy with school. They had time to attend extra classes. But now, the school timings have been extended. And even if your school time is the same as it was earlier, you have a lot of work to be completed. Whatever, writing social studies classwork, science classwork, this, that, assignments, slip tests. So children are so busy. So I cannot take you to task. Like I cannot question you why you did not complete the assignment. I just assume that, you were occupied with your school work It was not negligence.
Yes,
It is
ma'am.
a-
Tests every day in our school, ma'am. And our school is still 5:30, ma'am.
That's what, yeah. And weekend, you have to study the other subjects also. You cannot do maths always.
Yes, ma'am.
Yeah. So please don't neglect children. If you have time, don't think that anyways she's not going to scold me, or what can she do with me in an online class? Nothing can be done. So don't misuse that. If you have time, please try to complete the assignment. You will be benefited out of it. If you have a good reason for not doing it, then you will not feel guilty. So if you have time, please complete the assignment. And I'm not questioning any one of you here as to why you didn't complete, because I assume your school keeps you busy during the weekends. Now this one, children, yeah, I have nothing to explain in this paper actually. The whole paper I have nothing to explain. Please complete it in the class now. I'll just show you the answers. Please work it now in the class. So how many roots can a cubic polynomial have? Check if minus 1/2 is a root of the polynomial p of x. Write down, children. Please complete the answer now. Okay, Danya, you have shared a picture with me. So that was the assignment given on Wednesday and was discussed in the Friday's class. Danya?
Yes, ma'am.
Yeah, these answers we have already discussed in the class. Are you aware of that?
No, ma'am, I did not attend the last two classes as I had exams, ma'am.
Friday's class you didn't attend?
No, ma'am.
Oh, okay. The meeting recording, I don't have to send it every time. I think I told the class about this. I don't have to see. Yeah, I think I told you about it. So you have the playlist link. Use the same link. I don't have to send the meeting recording every time to you. So for polynomials, we have one playlist link. So every time I update the playlist link, the video will be there. So you just have to use the same link. There's only one link for one chapter. There is only one playlist link for one chapter. So for polynomials, I've already shared the playlist link with you. You can use the same link. When I download the meeting recording and upload it there, the playlist will be updated. So you can use the same link. I don't have to send it every time.
Yes, ma'am.
Yes, children, all of you complete this one. Sorry. Okay, I'll just 1 minute. Let me do this. I'll just show you all the answers, children. I'll just show you all the answers. All of you take screenshots, complete it now. And I want each one of you in the class to take pictures of your today's work and share it with me on WhatsApp. Let's do that regularly. From this class onwards, what you have to do is at the end of every session, you'll have to take pictures of your classwork. All right, and share it on WhatsApp with me. Just to make sure that all of you are writing in the class, because some of you are not communicating with me at all. From today, after the session, after each session, please take pictures of your classwork and share the same with me on WhatsApp. There is no group. There is no group. Send it to my number. Yeah, so I'll show you the answers. Take a screenshot, complete it now, and share all the pictures, this one and the earlier assignment, what we discussed today. Send all the pictures to me on WhatsApp, all of you. Yeah, this is the second one. The first one, take a picture.
Taken, ma'am.
Okay. Second one. Third one. So here directly it is given that x is equal to 2 and x is equal to 0. It's not given x minus 2. It's not given x minus 2. X is equal to 2. The value of x is 2. The value of x is 0. So you should find f of 2 and f of 0. See how it's given. X is equal to 2 and x is equal to 0 are roots of the polynomial. X is equal to 2, x is equal to 0. So that means the value of x is 2, the value of x is 0. Yeah, take a picture, children.
Taken, ma'am.
Long division, and I've shown the steps here. You can see the working here. 3x, this one divided by this one gives you the first term. Put the first term here, and then you'll have to multiply 3x square by x square. Dear children, multiply 3x square by x square. This 3x square by x square, and the answer is this. That's the first term. And then you should multiply 3x square by minus 5 by 3, minus 5 by 3. So 3 and 3 will get cancelled, minus 5x square. That's the second term. You can see the working here for every step. I've showed the working here. And this is the x square term. So write it below x square. Then bring the 6x cubed down, this one and this one down. Again, divide this by this. So you can see all that here. Multiplication, you can see everything here in the working. Take a screenshot.
Taken, ma'am.
Yeah,
Taken, ma'am.
all right. Done?
Yes, ma'am.
All right.
Can you show me a second question, ma'am?
Yeah, sure. Second one, no? Second answer.
Yes, ma'am. Yes, ma'am.
Yeah. All right.
Okay, ma'am.
children.
Thank you.
Yeah. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thank you.
children.
Thank you, ma'am.
Thank you, children. Thank you.
Thank you, ma'am.
Thank you.